Hello there. In this video, we are going to take a look at using exact arithmetic with the QPython package. You may, in many cases, not need to use exact arithmetic, but in some cases, if your results are being affected by the numerical precision being used by Python, which is by default, the floating type, you can instead use an exact decimal type provided from the Python standard library. And Q has actually built this into the package as an option. So let's first create a little example here. Let's import Q, and then we'll define a network, Q dot, and our usual create network here. We'll give some rival distributions, Q dot dists dot, we'll do the usual exponential distribution for now. And we'll do some service distribution. We'll say a rate of 10 just so it dominates the arrivals. Number of servers, we'll do 1. Okay, so we have a network. To define the precision of the simulation is not about how you define the network as it is about how you initialize the simulation. So if I go and define sim is a simulation class. You have hopefully seen in the other videos that to create a simulation object, we just need to do this. However, we can set this exact either as a bool or as, actually I might have to go dig into the source code of Q. Maybe this is not supposed to be a Boolean because the official documentation says for it to be an exact equals an integer. And that may be that you want something like 26. Yeah, so it's getting annoyed by the type system, but I'm pretty sure based on the docs that this is correct. Okay, that might be a bug fix. So if I want to actually run this simulation, it should look the same from here on out as all the other simulations that we've done. Maybe we set a seed. In fact, I think I went on to do that before setting the simulation object up. And then with our simulation, we can simulate under different conditions. We'll just go until maximum time. In this case, I'll go 100. And I should say, when we're talking about this exact arithmetic, I should clarify that it has to do with the exact arithmetic of time. If you've got other kinds of numerical quantities that you've brought into the simulation that have decimal precision, they may or may not enter into any of this because this is mostly about the clock time being exact. Okay, so I might extract something like the weights, going record dot waiting time for record in, and we'll grab all the records, get all records, and maybe we'll print the last entry in weights, and let's just double check that this works. Good. So this works as expected. I think that this is actually a misspecification of the type, which I'll probably make a pull request shortly for. You should probably put in a number here because this is supposed to be the number of decimals that your simulation is going to be exact to. So what this basically allows you to do is, if you're finding that the results are wrong because of floating point precision, that you can expand the precision that you're doing your calculations with, and that will hopefully resolve the issue for you. With that, I'll see you in the next video, and have a great day.